Hello, my name is Jay Martin, and my call sign is N2NVY. I'm an amateur radio operator located in western North Carolina. I wanted to share a tool I've been working on called MicroGrams. It's designed for transmitting structured information across data-constrained communication paths. MicroGrams was inspired by concepts already in use in the amateur radio community, specifically MC forms on JS8Call, or microforms as they're also referred to. If you're not familiar with those, I'll touch on them a little later in the video. I really liked the idea behind microforms and wanted to explore how that same concept could be expanded beyond one specific mode or application. I'm not currently aware of microforms being used in other modes, but I do know they were developed for the JS8Call platform. Another JS8Call companion application called ComStat uses a similar message type payload. It has what's called stat reps, and you'll see that traffic on JS8Call. The thing with both of these applications is that there's a bit of a learning curve, especially with ComStat. What I wanted to do was build something that was easy, lightweight, and didn't require a lot of overhead to generate and decode messages. I also wanted it to work across a variety of platforms. Most of it is simple HTML, making it easy to access, download, and keep a copy wherever you need it. MicroGrams uses a process commonly called template-based compact messaging, or form-based serialization. The basic idea is simple. Both the sender and receiver have a matching template, almost like a shared key. That template contains the form layout, the questions, the field order, and any available options for each field. Instead of transmitting an entire report like station operational, personnel safe, fuel at 50%, batteries charging, the sender only transmits the important values. When the receiver gets a microgram, their copy uses the same template to reconstruct the incoming text string into a human-readable report. Those values are converted into small numbers, letters, or text strings that can travel across a restricted communications path. The result may be a message that's only 8 to 10 characters long, yet still contains all of that information. Some people might ask, are you sending encrypted or coded information over amateur radio? As long as you publish where users can find the template you're using, you're fine. If you don't publish it, then you could be violating the rules regarding encoded transmissions on amateur radio frequencies. There's no problem. If you're using the forms we provide on our website or forms from the public repository, everyone has access to those templates. If you'd like us to add one of your forms to the repository, we can do that. Or if you'd rather host it on your club's website or your group's website, that's perfectly fine as well. You just need to indicate where people can find the template, usually within your payload message. I give an example of how I do that, and you can come up with your own solution. We'll talk more about that a little later. This approach works well for amateur radio and emergency communications, especially in situations where bandwidth or message length affects your ability to efficiently communicate. Modes like APRS, mesh core, and even some packet modes benefit from this. If you send a large message, it requires more airtime to transmit, decode, and receive. If you can reduce that large message to just a few characters, you significantly reduce the on-air time for both the transmitting and receiving stations. We'll cover some examples of that throughout this video. This is my first demonstration video for MicroGrams, so bear with me as I get better at showing how the tool works. This project is under active development, so if you notice something that's incorrect or something changes after this video is published, let me know. I can update the video or the information available on the website. You can contact me via my info on QRZ for any questions or feedback. The goal is to provide a simple tool for creating compact structured messages. I build it both so you can use it online, and there's also an offline version that you can save to any device with a web browser and launch locally. It's lightweight and very accessible. You don't need a specific operating system or program to generate or decode these payloads. This is simply a browser-based tool with everything built into it. All right, let's get into the tool. This is the main page for the website. It may change a little between the time you watch this video and future updates, since the project is still under development. You'll find information about what the tool does and how to use it. I always include this important note to remind users that both the encoding and decoding stations must use the same version of the repository or the same forms. Otherwise, you'll end up with incorrect information. I try to make that very clear throughout the website. Let's go straight into the online version of the tool. There's also an offline version we'll cover later, but let's start with the online site. Click the online tool link and it'll take you to the main interface. This is where you can both encode and decode messages. If you've received a payload that you want to decode, simply come over here, click Decode, and the tool will interpret it for you. Even though it looks like there's a lot of information on this page, there really isn't. If you hover over the question marks, you'll get descriptions of what belongs in each field. Some fields are optional. For example, if you're using a mode that requires addressing another station or sending to a group, you can fill in the to and from fields however you'd like. There's a section for a cross-mode tag. For example, if you're sending your payload over APRS, you'll notice that not a lot of traffic that looks like a microgram is being sent. Someone might wonder what it is. You can include a tag that identifies the payload. If they're curious, they can do a quick search and easily find out what it is. This also helps ensure we're not sending encoded traffic over amateur radio in violation of Part 97. I've spelled out MicroGrams, and I also use the hashtag MCGFM. If someone searches for that tag, it'll bring them to this website where they can learn what it is and how to decode it. You can also include authentication codes in your payload. If you want the receiving station to verify an authentication code, you can include it here and it'll automatically be built into the payload. When working with different communication modes, there are character limits. We include a reminder down here, and you can also set a target warning. If your payload starts getting too large, the tool will notify you. For example, you could set it to 200 characters. If you were using MeshCore, or if you're using APRS, you might set it to 67 characters. When you're ready to choose a form, simply browse the library. The tool loads all available forms from the repository. For example, under General Information, Non-Emergency, you can select the form you want to use. As you become more familiar with the tool, you'll quickly recognize which forms you need. If you're new to MicroGrams and want to see what's available, click Forms. The repository lists every form, where it came from, and a brief description of its purpose. If you'd like to examine a form more closely, click Use in Tool. That loads the selected form directly into the encoder so you can begin filling it out. Let's build one together. I'm not going to address this to anyone specifically. Let's say I'm sending it over APRS, so I'll use the hashtag MCGFM. I'll use an authentication code of TYT, and I already have my warning limit set to 67 characters. Everything else is ready to go. Now I'll simply select my time offset and answer each question in the form. In this example, I'm filling out an amateur operator information report, perhaps because someone requested it during a net. Once you've completed the form, you'll see three different output options. The first is the raw payload. This is simply the completed form encoded into its compact format. You can see the F100 form identifier, followed by the answers, the comments, the encoded date and time using the hashtag and 4-character time code, and finally the authentication code at the end. This raw payload can be transmitted over any communication mode you choose. If you're using JS8Call or JS8Spotter, you can usually copy this directly into your message. Most of the time, it'll be identical to the raw microgram payload. The only difference is if you've added special routing or destination information that's specific to a particular application. Below that is the cross-mode version. It includes the MCGFM tag followed by the payload. That way, if someone encounters the message and wonders what it is, they can search the tag or contact you to learn more. The search will lead them back to the website where they can understand and decode the message. I'll copy the cross-mode payload. Now let's send it. This is Pinpoint APRS, which recently received some nice updates. I'll create a new message and send it to KO4PWP. I'll paste in my payload. It includes the identifier, the authentication code, and the comments. Everything fits, and I still have 15 characters remaining. I'll press send. The message has now been transmitted. You can see it appear in the outgoing traffic. If I switch over to APRS.FI and look at the raw packet information, you'll see the payload there as well. At this point, the message is available. If it reached an iGate, it's now available worldwide. If it stayed on RF, another station monitoring that frequency could receive and decode it. Keep in mind the pitfalls of relying on APRS, as you're not guaranteed packet delivery with every message. You may want to retransmit or beacon this kind of message for a period of time. Now let's look at the receiving side. Suppose this payload arrived over APRS, Meshtastic, or another supported mode. To decode it, simply return to the tool and select Decode instead of Fill and Encode. Paste the payload into the decoder. As soon as you do, the tool reconstructs all of the information contained in that message. It identifies the form, displays the date and time, shows the authentication code, and lists all of the answers along with any comments. In this example, we transmitted a 47-character payload over a limited bandwidth communications path and successfully delivered a complete human-readable report. Some forms are much larger, especially things like area update assessments. This example demonstrates how you can move structured information using only a 47-character payload. If you're monitoring JS8Call, you'll occasionally see payload formatted messages appear, especially if you're subscribed to the @sitrep group. When a message comes in, you'll see the notification flag, click it, then open the message inbox to view the received messages. This message came in a little earlier today. I saved it so I could use it in this example. You can decode these messages directly with the MicroGrams website. Let's take this F105 report and see what information it contains. After you've worked with these reports for a while, you'll start recognizing certain forms. For example, many F104 reports, with several ones, simply indicate that conditions are normal. Let's decode this one. We'll get a good update along with the timestamp. I'll copy the report, then switch back to the MicroGrams website. I'll launch the tool and open the decoder because I want to see what's contained in this message. Remember, this transmission could have come through any supported data path. It could have arrived via APRS, a WinLink message, text message, or another transport. Just paste the payload into the decoder exactly as you received it, and the tool will reconstruct the original form. You'll see the time the message was sent, the name of the form, and all of the information contained within it, including any comments. That's how you recover structured information that comes across a restricted communications path. Now let's look at a couple of unique situations. Suppose the formatting of a payload changes during transmission or while being copied between different modes. You receive a payload, go to decode it, and it doesn't work. If someone accidentally removes those spaces before sending it, the decoder won't be able to parse the message correctly. To help with that, we've built in a recovery feature. If the payload can't be decoded, you'll receive an error indicating it couldn't be parsed. Below that, you'll see an option labeled "Attempt to fix this payload." When you click it, the tool analyzes the payload and attempts to restore the missing formatting. You'll see the spaces added back in, and in many cases, the message can then be decoded successfully. Of course, if part of the transmission was actually lost or corrupted, there's only so much the software can do. For example, if several fields were completely missing, everything below those fields would shift out of position. Normally, unused fields are represented with placeholder values, so the field order remains intact. This recovery feature isn't foolproof, but if the only problem is missing spaces or extra characters in the front or rear of the payload, it often allows you to recover the message. Otherwise, you may simply need to request a retransmission or ask the sending station for clarification. Another useful feature involves local forms. Suppose you've distributed custom forms to your club or emergency communications group and you're operating completely offline. Maybe you're running an exercise or responding during an actual deployment. You can load local forms directly into the encoder and decoder. To do that, choose Open Local Forms. Browse to the form on your computer. In this example, I've created a modified 9-line medevac form with my own numbering, simply to demonstrate how this works. Once you open the form, it becomes available just like any other repository form, and you can fill it out normally. Let's say I've completed the form and transmitted the payload. On the receiving station, I would follow the same process. I'd load the same local form, paste in the received payload, and the tool would decode it correctly. Both the sending station and the receiving station must load the same local form before encoding or decoding the message. I hope that makes sense and is key for proper message delivery. One additional note, I'll be creating a separate video that covers the offline version of the tool. The offline version is designed for computers that aren't connected to the internet and are receiving traffic only over RF. The process for loading local forms is nearly the same. Open the form library, choose Load Local Forms, and select your custom form, just as we did with the online version. Once you've loaded it, return to Fill and Encode, select the form, and you're ready to use it. You don't need an internet connection to use the tool. When updates are released, they're incorporated into the offline version as well. That's why it's important to keep both the encoding and decoding stations running the same version, or at least make sure they're using the same forms. That covers the basic overview of MicroGrams. I'll be creating additional tutorials that dive deeper into some of the more advanced features, such as building your own forms and adding them to the repository. For now, I wanted to introduce the tool so people can start using it in whatever way works best for them. The possibilities are wide open. You could even use this over standard text messaging if it fits your application. We'll continue developing the project, adding new features, and making it even more useful over time. The goal has always been to create something that's simple to use, lightweight, and capable of running just about anywhere. That's the direction we're continuing to move. I also plan to build custom forms specifically for my geographic area so they can be shared with other operators in the region. If you're building forms or using MicroGrams for your club, organization, or emergency communications group, I'd love to hear from you. Please let me know how you're using MicroGrams, as I'd be happy to collaborate and highlight your implementation so others can learn from it. Again, my name is J. Martin, call sign N2NVY. Thanks for watching this introduction to MicroGrams.